Today's flip lesson will be on creating a graph. So why do we create graphs? We create graphs for the following reasons. It visually represents collected data. It allows the reader to see trends in the data. It allows one to make predictions, and it can be used as a mathematical tool. But what are the steps to creating a graph? Well, first, you need some data. So here's some data on distance versus time. It seems to the observer that as time increases, distance increases. Let's take a look at that visually. To begin our graph, let's get some paper onto our table here. That's a good size. And let's include our original data of time and distance. The first thing we need to do is have a title for our graph. The title should say something about the two variables that will be graphed. In our case, this would be distance versus time. This is normally labeled at the top of the graph as shown. Okay, so we know we need to graph distance and time, but on which axes do these things go? From math class, you know that this is the y-axis, and this is the x. In our case here, we'll plot time on the x-axis. We always want to know what's going on with respect to time. Therefore, distance will be on the y-axis. It's important when you label the axes that you include the units. So I have distance in meters and time in seconds. Now we need to draw the lines that represent the axes. When you draw these lines, be sure to use a straight edge and a ruler to make the lines nice and straight. Probably the biggest problem for students is setting up a scale for each axis. So we'll do that independently. We'll do time first, and then we'll do distance. If you count the number of boxes along the time axis, you'll find that there are 15 boxes. And I have time starting at 0 and ending at 5. You may want to go 3 boxes represents each second, but that's kind of an odd number. So let's do 2 boxes is equal to 1 second. When you set the scale, it's important to keep the same amount of increments for each number. So here I've written in the time using 2 boxes to represent 1 second. Can you guess the interval I used for the distance axis? When choosing a scale, try to use as much of the available graph paper as possible. We're almost there. It's now time to plot our data. So it's important to make sure that you plot it correctly. So let's look at our first data point, 0, 0. Well, that one's pretty easy. That occurs down here. Now we go to our next data point, which is 5 to 1. So we'll put that data point in. 10 to 2 is our next one. 15 to 3 is our next one. 20 to 4. And then finally, 25 meters in 5 seconds. Now after you plot the points, you have a decision to make. Does this look like it would be a line or a curve? In science class, we never connect the dots. It's always going to be what we call a best fit line or a best fit curve. This data plotted as such appears to be a best fit line. So using a straight edge, you'll draw a line. Here's our best fit line in blue. So what do you notice about our graph? We see that as time increases, distance is increasing. And we see for each unit of time, there's an equal amount of distance going up. In this case, it's 5 meters for every second. So why did we graph it? Well, now here we can make some predictions. Using your graph, predict where the object would be at 2.5 seconds. To do this, we start at 2.5 down here at the bottom and go up to our graph, where it hits right there. And we go across, and that's where the object will be at 2.5 seconds, which is roughly halfway between 10 and 15 meters. so about 12.5 to 13 meters. Now where would the object be at 6 seconds? Well, that's not even a data point we graphed, but we can actually take a look. If we put 6 here and then do the same thing, we go up and then we'll go over, and although we didn't plot it, we can see that if each of these two boxes is 5, this would be 30. So at 6 seconds, the object would be at 30 meters. Now we'll look at another set of data, showing the pH of water and how it relates to the number of tadpoles. If you look at the data, it's hard to tell the relationship, so let's graph it. I will show each of the steps without the narration. Here you can see I've labeled the graph and also labeled the y and x axes. pH of water goes on the x-axis because it is the independent variable. The number of tadpoles goes on the y-axis because that's the dependent variable. Here I've labeled the pH of water axis, or our independent variable. Can you guess what my scale was? How about the scale for the number of tadpoles? Now we'll plot the points. This is a strange looking graph. Again, we're not going to connect the dots, but we're going to draw it nice and smooth. When drawing graphs, it is important to get as many points on your graph as possible. You can see I didn't do such a great job, but you get the general sense. A researcher would predict that at 6.5 pH is the optimum pH level for water for tadpoles. Here's our last example. This time you won't hear me talking at all, and you can check to make sure that everything's done correctly. So here are our plotted points. Does that look like a best fit line or a best fit curve? The last thing I want to talk about this graph is how would you describe it in math class? In math class, since this is a line, we would say it's a linear graph. And in fact, as one thing increases and the other increases, we would call this a direct linear. There are a whole bunch of different graphs, and really the only thing that's different will be the data that you plot. Take a look at this graph. Well, this certainly isn't a line, and it's kind of a curve, but if you look, this pattern repeats over and over again. In fact, it repeats for 2.5 cycles. Something that's repetitive like this we call cyclic or cyclic. There will be many times when we graph something like this. You may even graph something like this in our class. Notice how this is also a position versus time graph. However, it has a much different shape. This we would call a best fit curve, because clearly that is not a line. Or how about this graph? Here we see, as mass increases, going this way, the acceleration's going down. When you have a relationship like that, we call that an inverse relationship. So let's summarize what we have learned in today's flip lesson. First, once you have your data, you need to title your graph. And you need to label the axes. The independent variable goes on the x, and the dependent goes on the y. Then determine a scale that will fit on the graph and is uniform. That is key. We'll practice that in class. Then you're going to plot all the data points. Then draw a best fit line or curve, but we do not connect the dots. And thanks for watching my first flip lesson.